Okay, so today we're going to be going over the different exponent rules. So basically, I'm going to be telling you what to do when you are multiplying, dividing, adding, or subtracting. We'll go over negatives and zeros and just all the good stuff with the powers. So, starting off strong, we have our product and our quotient rules, and both of these are kind of what they sound like, so multiplication and division. So, first we have our product rule, which is that x to the m times x to the n, m and n just being random powers, is going to be x to the m plus n. So whenever you're multiplying exponents, you're going to add the exponents. Okay, so I'm saying x cubed times x to the 6. I'm going to say, okay, x, the base, stays the same, so I'm going to write that right there. And then I'm going to add the 3 and the 6, and so we'll get x to the 9th. This would also apply if you had like x to the 4th times x squared. You would take 4 times 2, and it would be x to the 8th. So moving on, we have our quotient rule, which much like multiplication and division being the opposite of each other, these rules are the opposite. So when you're dividing x to the m over x to the n, you're going to be subtracting those exponents. So you're going to subtract the top from the bottom. And so you're going to end up with x to the m minus n. So here we have x to the 5th divided by x squared. So you're going to take 5 minus 2, and you're going to get x cubed. So this would also apply if you have negative numbers. You're just going to do it the same way, and you're just going to subtract it but include the negative. So if you have negative 5 minus 5, then it's going to be x to the negative 10th. And then we'll go over what to do with that negative in a second. So moving on, we have the easiest rule, the zero rule. And that's basically that anything to the 0 power is 1, with the exception being there it is, 0 to the 0 power, which is going to be 0. Just anytime 0 is multiplied to anything, it's going to be 0. However, when 0 is the power, the response is always going to be 1. So x to the 0 power, 1. Y to the 0 power, 1. 189 to the 0 power, 1. 276 to the 0 power, 1. It could be any number, and if it's raised to the 0 power, with the exception of it being 0, the answer will always be 1. So that's an easy point on your test right there. So moving on to the product, to the power rule. Pretend that this says power. So that's going to be x to the m, parentheses, and then n next to it. So it's similar to the product rule, which is the multiplication. That's why I got it mixed up. But basically, when you see the parentheses right here and you see it being raised to another power, you're saying like, okay, x to the m power raised, like that collective thing raised to another power. So you have like, I don't know, 3 cubed in the parentheses, that's going to be 27, and then you're going to be raising that up another power. So you're going to have a really big number from that. So because think that when you're getting that big number, you're going to need to do things that are going to make the number bigger. So you can't just add, you have to multiply. So you're going to have x to the m to the n. So you're going to multiply m and n. So here we have x to the 4th squared, like that collective thing squared. So you're going to multiply the 4 and the 2, and you're going to get x to the 8th. So similar if you had like y cubed collectively raised, I don't know, to the 5th, then you're going to take the 3 times the 5, and you're going to get y to the 15th. Okay. So our last two rules are going to be the expanded power rule and the negative rule. So the expanded power rule, sorry, the side looks complicated, but trust me, it's not. You got this. So the expanded power rule is essentially saying whatever applies to the first term is also going to get applied to the second term. So if I'm saying I want x and y collectively raised to the m power, then when I'm writing that out and I'm like furthering the expression, I'm going to want x to the m, y to the m. So basically, if you have x and y to the m, you can't just be like, oh, I'm going to give x to the m, but y gets nothing. Nah, you got to distribute that m to everybody involved. Same thing goes for when you're dividing. So if you have x over y to the m, then it's going to be x to the m over y to the m. So basically, you just got to distribute that to each of the terms. So over here, we have the examples. So I have x and y collectively raised to the 3rd power. And so you're going to distribute the 3. So x cubed to y cubed. And then x over y to the 5th power, you're going to have x to the 5th over y to the 5th. So basically you're just saying that each term within that is going to get raised to the power as well. So finally, we have the negative rules, which is less of like a rule. I guess it is. It's more of what to do when you're faced with a negative. So here I have x to the negative m. So pretty much you're just going to flip it. So if you have x to a negative exponent, you're going to put that under the denominator. So if you think about it, like x to the m is already like over 1, you know? Like just like any statement, like 5 is technically 5 over 1. 140 is technically 140 over 1. So here we have the x to the negative m power, which is like technically over 1. So to cancel out the negative exponent, you just flip it. So you're going to end up with 1 over x to the positive m power. And so same thing goes vice versa. So vice versa. So if you have 1 over x to the negative m power, you're going to flip it. So then you have x to the positive m power over 1. So this one, it sounds kind of hard, but once you practice it, you'll get the hang of it. Like really, you're just flipping it and the negative goes away. It's super nice. So we have x to the, x to the negative 3. So I'm going to go, okay, I don't want the negative, so I'm going to flip it and just put it under 1. So 1 over x to the positive 3. And then we have 1 over x to the negative 2. I don't want the negative there, so I'm going to flip it and get x to the positive 2. Basically, you never want a negative exponent in your answer. You're always going to want to flip it and either turn it into a fraction or take it away from the fraction. And also, if you have a negative exponent already in the bottom of a fraction, you can take just that term and bring it up. So if you have 1 over x to the negative 5th times y to the third, the y to the third is positive, and you can leave that in the denominator because if you bring it up with it, then the y is going to have to become negative. But you can take just the x, which is raised to the negative, put that in the numerator, and then you got all positive terms in your answer, and you are good to go. So those are your 6 rules of exponents. I made some notes and some practice problems and a key, so hopefully you should be able to see that linked on the math website. But yeah, so hopefully that helped. Thank you so much.